Moving on now to topic 4, our last section of chapter 2. We're going to look at introduction to curve fitting and the point slope form of the linear equation in two variables. Now you may recall this was formula number 4, and that was the one we hadn't done yet at all. And it's y minus y sub 1 equals the slope times x minus x sub 1. So we said that if we had the slope and one ordered pair member, and we put it into this formula, it would generate an equation, usually in formula 2, which is y equals mx plus b. So that's where we're going in this section. So there's the equation, and the formal name for it is the point slope form. And there's your 1 point, and there's the slope. And slope and 1 point. So find the graph of an equation of a line passing through this with this slope. Okay, what we're going to do is set up the equation y minus y sub 1 equals m times x minus x sub 1. Now this is an equation I've memorized. We're calling that equation 4, by the way. So here's what you do. Where you have the m, we're going to put 2/3. And this is the y. We're going to put a 9 there. And then this is 4. We'll put the 4 there. Okay? So we now have y minus 9 equals 2/3 x minus, now 2 times a negative 4 is 8 over 3. And now what we're going to do is transpose this negative 9 over to this side as a positive 9. But we can't really join it, can we? Because this is a whole number and this is a fraction. So what we need to do here is convert this 9 to a number with a denominator of 3. So we're going to times it by 3 over 3. And then this gives me then, I guess I can write it down here, 8/3 plus. So this is 9 over 1, remember, becomes 27/3. Now I can do it. So y equals 2/3 x plus 19/3. And that is the equation now in slope-intercept form. So notice it has the slope. What we had to find out was the y-intercept. So there's the formula. There's the substitution. There's the graph. And, well, they're jumping ahead here to a new problem. So let's go. Write the slope-intercept equation for the line with the slope of 3 and this point. Well, again, it's very similar. Y minus y sub 1 equals m times x minus x sub 1. So we're going to do some substitution. Our slope is 3, so we put a 3 there. Our y is 3, so we put a 3 there. And our x is 4, and we put an x there, or a 4 there. All right, let's go on. So we have y minus 3 equals 3x minus 12, just distributing. And now we'll transpose that. This becomes a positive 3 on that side. So we now have the equation y equals 3x minus 9. Now every once in a while they want us to put it in standard form. So we would do that by taking this term, transposing it over to that side. That then becomes a negative 3x plus y equals a negative 9. And sometimes they don't want this to be negative, this a term here. So we just multiply everything by a negative 1. And this will then become a positive 3x. This becomes a negative y. And this becomes a positive, which we don't write the positive sign, 9. So just multiply everything by a negative 1 just changes all the signs. So there's our point slope form. There's our substitution. And now we bring the negative 3 over, and it becomes a positive 3, and adding it to a negative 12 gives us a negative 9. Okay, a couple of key words here which I think are rather interesting. I'll give you a moment to read this. And that is interpolation and extrapolation. Now I'm making the first quadrant of a graph, and let's suppose I have some data, and the data of the line looks like so. But that's all the data that I have. Now, if I had more data, which I don't, but it's continuing in the same pattern, I might indicate a dotted line here. I don't have this data, but we're extending this pattern of data we have into the future of data we don't have. Now, picking out anything along the blue line of known data, that's called interpolation. Picking out data beyond our known data, keeping in the same trend, that's extrapolation. So we often use this. Well, if we keep this pattern, we're going to extrapolate into the future. That's how they do it. And that's what that's all about. So here they're saying that a person, when they do aerobic exercise, and aerobic refers to oxygen getting into your bloodstream, and oxygen is very important for good health, because without it you die. A person's target heart rate is the number of beats per minute that brings the most aerobic benefit to his or her heart. The target heart rate for a 20-year-old to do this is 150 beats per minute. That is, you get out there and get your heart really working. But for a 60-year-old, it drops down to 120 beats. Now, graph the given data and calculate the target heart rate for a 46-year-old. And then calculate the target heart rate for a 70-year-old. So we've made our graph, and this is the first quadrant. And there's our line there, or point there, and there's a point there. So what we're going to do is we're going to make a line up through here, like so. And we could extend it this way a little bit too, keep it more or less like so. Now, notice you had two items of data initially. You had a 20-year-old having 150 beats per minute. So there's the age 20, and there's that ordered pair. Then later you have a 60-year-old 120. So there's the 60-year-old, and there's 120. Now, what would it be? I think they asked for a 46-year-old. Well, 46-year-old is, here's 45, so it'd be right about there. And if you went over 110, 120, 130, it's going to be about 130. See if I can make it 3. There we go. So that would be a guesstimation. You have data for these 2 points. So this is an interpolation of your data. Now for a 70-year-old, you didn't have that data, but we extended the line and we got right about there. And that's going to be about 112. So this part out here really should be a dotted line. Nope, well, I didn't make too good a dotted line there. Something like that. Now, that's using the graph and then sort of guesstimating a little bit. But what could we have done if we wanted to make it a little bit more mathematical? Well, we have 2 pairs of data. Could we find the slope from that? Ah, yes, we could. And if we found the slope, could we then use the point slope form and use either one of these points to get an equation of the general pattern of that line? And that's what we're going to do. So there's the slope, and it comes out to be a negative 3/4. Now, using that, we then put it into point slope form, which we've done. And we're going to multiply through and then transpose this. So we end up with this particular equation of the heart rate for aerobics and those particular ages. Now, if you notice what we did, we had made that line and we said it's going to be about 130. Well, if you put 46 into that formula, you actually get the exact reading, 130.5. So this is interpolation of data we already know. Now, if we put the 70 in there, we didn't really have that data. We find it's going to be about 112.5. Well, that's actually exact. Now, over in this part, since it was extending our data, that's extrapolation out here. Within known data, intrapolation. Outside of our known data, extrapolation. Okay. Now, when we look at data, we sometimes wonder, is the data linear? That is it sort of a straight line? And we interpret this through a process called data analysis. And we also use the term curve fitting. We're trying to describe what's happening to that data, and I'll show you in a moment what we mean. So here we see graph A and graph B. Which one appears to be linear? Well, it's quite obvious it's going to be B. This is almost a straight line, or it is a straight line. In fact, if we take our line tool, and I don't know why it's doing that, but we kind of line up our points, yeah, that's a straight line. Now over here, we know the trend is going this way, and in fact, if we kind of link the points together, we see the general trend is increasing, but this data is not linear. But sometimes what we do to our data is we look for an average line. So we might go something like this. If I can here, let's see, there we go, that's better. So this would be an average line where we're kind of averaging our data. So that would be curve fitting. We're taking a curve and sort of fitting it into a straight line. But this data is actually linear. This is not linear, but we have curve fitted the data. Okay. You'll be working on your quiz-me's, your practice first, your quiz-me's, and then you're getting ready for your test. Remember, your average of your mastery will be worked into your raw test score. And you'll need to practice your skills of graphing. This is going to be a lot of graphing on your test.